I hope you all are fine, okay, and studying physics, right? The topic we have selected today is Joules law and its applications. So today we are going to state and verify Joules law and are going to study its number of applications. So let's proceed. Now, Joules law of heating states that heat produced in a device or in a circuit depends on or directly proportional to the square of the current flowing through it, directly proportional to the resistance of it, and directly proportional to the time for which current is flowing. So H is directly proportional to I square R T. To remove proportionality and to have equality, let us consider a constant K whose value investigation suggests as 1. So we have mathematical form of Joules law as H is equal to I square RT. So we can easily identify heat produced in any of the device or a conductor or a machine is directly proportional or depends upon the square of the current, resistance of the device, and the time for which current is flowing through it. In simple language, if current flows for a longer time, it becomes more hotter. If the device has a greater resistance, it will gets heated up more, and current का magnitude अगर ज़्यादा है तो heat will be more. So let's prove this and later on we'll learn its application. So how to prove? It's very easy. We'll consider a simple circuit. There is a circuit, we have a device, say for example bulb, okay, connected across a battery, okay, key, ammeter, if you wish to keep, you can keep the ammeter. To measure the voltage, we can have a voltmeter in parallel, plus, minus, this is plus, this is minus, then this is plus, this is minus, right? So current will move from positive terminal of the battery to the negative. Suppose the resistance of the bulb is R. R is the resistance of the bulb, I is the current flowing through it, and V is the voltage across it. So what we can have, we know that from this circuit we know electric potential difference is the amount of work done to move a charge from one place to other place, right? This implies that W is equal to V into Q, right? Let me tell you, this is electrical work done, this is electric potential difference, and this is electric charge, right? Now, we know that, therefore W is equal to V into Q, but electric current is nothing but rate of flow of charge, so the value of Q is I into T that can be replaced. So W goes as V, value of I will be I into T, so we have W is equal to VIT. Now this electrical work done is stored as heat energy. In 9th standard, we also study work and energy are interconvertible. So this electrical work is stored as heat energy. So we can write as H is equal to VIT. But Ohm's law tells us, Ohm's law is V is Ri. So I can replace this V by R into I. So I can have this H Ri, that's Ohm's law, I into T. This I into I will be I square. So H is equal to I square R into T. This is the required form of Joules law which we got. This is one more form of, okay, right? Now, let us go for the applications. So we understand heat produced can be I square RT or else VIT. If you replace the value of I from Ohm's law, what is Ohm's law? V is equal to, Ohm's law tells us V is equal to Ri. So I can be V upon R. So if you replace this I over here, V into I, that's V upon R will be V square by R into E. So this is how we can have Joules law in its various form. Now let's learn the various applications of Joules law. Joules law have multiple applications. So let's study one by one. Applications. First, electric bulb. Now if you might have seen electric bulb, it looks like this. We have a filament inside, and that filament is covered by a glass envelope, okay, and then we have two terminals, one is positive, another is negative terminal. This is what your tungsten, this is what your glass. Now see what happens. This tungsten has very high melting point, 3386 degrees Celsius, the melting point of the tungsten, and it has very high resistivity. It has very high resistivity, and this resistivity creates lots of heat. So what happens? This tungsten filament gets heated up, and part of it gets converted into light, and we get to see when bulb is glowing. This is the simple physics and behind the working of bulb, and here we make use of Joules law of heating. जितना ज्यादा resistance उतना ज्यादा heat और उतना ज्यादा light create होगा. This is a simple application. Second application which everybody knows, that's electric iron. Okay, we use it for pressing. If you might have seen the structure of iron, iron is like this, right? If you see, okay. Now we have a base of the iron. This base is high resistivity, high resistance or resistivity, because it is made up of alloy. And the wire which is connected is a normal wire, that's a copper wire. Now current reaches to the alloy, which is the bottom of it. Since it has a high resistance, it will produce greater amount of heat, and that heat can be utilized for pressing. Similarly, we have n number of application of Joules law of heating, such as your electric iron, electric heater, electric geyser. This is how we can find the various application of Joules law of heating in our life. So what we learned today, we learned that statement of Joules law, it states that heat produced depends upon the current, depends upon resistance, depends upon time. Okay, then we verify Joules law by using the definition of electric potential difference. We also seen how this Joules law is applicable in our day-to-day life. So if you have any queries, do comment. Thank you, children.